What's up, guys? Now let's talk about network sockets as the foundation for communication for APIs. Let's get into it. So, the underlying network stack of APIs usually abstracts this inter-process communication, but how is it actually done? Popular API technologies such as REST, GraphQL, and gRPC, they all work differently, but at the most basic level, they all use socket interfaces for process identification, connection establishment, and inter-process communication. Basic requirements for successful communication between two processes or services that operate on separate network devices. They all have identification of devices on the internet, identification of processes on the communicating devices, steps or procedures to exchange data between those processes. So let's understand how sockets play an important role in maintaining these three requirements. So, what is a socket? A socket is an interface that creates a two-way channel between processes communicating on different devices. Processes running on the application layer use sockets as an interface to take services from the transport layer to establish communication. Interfacing requires an IP address and a port number to uniquely identify a process or application globally. The interface IP address plus port is referred to as a socket address. Two different sockets or endpoints are required for any two processes to communicate. Each process in a connection is recognized by its respective socket address. So, port numbers ranging from 1 to 1024 are well-known ports because they're mostly used as a standard for a particular service. For example, port 80 and 443 are used for HTTP and HTTPS respectively. The transport protocol TCP or UDP specified in the transport layer of the network stack is responsible for successfully exchanging data between these processes. Sockets enable the simultaneous creation of multiple communication channels on a single machine. So this diagram shows an example of multiple processes or services running on one machine, right? So they have like all different ports, different protocols, but they're all running on the same machine, right? And what is the maximum number of connections that can be established on one machine? Well, so the size of the port number is 16 bits. So the maximum number of ports is limited to this really big number, like 65,000. However, the answer is kind of tricky. There's like a 5 tuple information on a machine that identifies a typical connection, like the source IP, the source port, destination IP, destination port, the transport layer protocol, and any combination of the information above can increase the maximum number. So both the available memory and the computing power also limit the number of simultaneous connections a machine can handle. And so there are different categories of network sockets. Um, they can be categorized in two general types. There's stream sockets and datagram sockets. So let's talk about stream sockets. A stream socket creates a reliable end-to-end connection between two endpoints using a transport protocol like TCP and SCTP to transmit data between processes. Also utilizes the recovery facility of the underlying protocol, for example, TCP, to retransmit lost data during data propagation phase. A stream socket created on TCP can be different in different states with the following flags. Like there's the SYN flag, synchronization flag, the number in front of the synchronization flag is the sequence number of the packet being sent. There's the acknowledgement flag, and the number in front of the acknowledgement flag is a sequence number indicating the last successful byte by the removed peer. TCP numbers each byte of the connection in each direction. So then there's the finish flag. The number in front of the finish flag is a sequence number indicating the last successfully received byte by the remote peer. So TCP connection, if a sender doesn't get an acknowledgement of the sequence after a defined period, the data is considered lost and a transmission is initiated. The initiator of the connection doesn't necessarily have to close it. Any connected partner can request termination and enter a receive only mode where it can receive but not send data on the channel. And after the other party finishes sending, the connection is closed completely. So now let's talk about datagram sockets. Unlike stream sockets, datagram sockets don't create an end-to-end channel between two endpoints to transfer data between processes. It just sends data and expects it to reach the receiver end. It's used in scenarios where data loss is not that important. It usually operates on a UDP-like protocol for data transfer. Communication is stateless and doesn't contain packet sequence numbers, so it's nearly impossible to identify data lost. There's no mechanism to recover lost data. However, there are protocols that work on top of UDP and use application-level sequencing to make the communication reliable. And there are also raw sockets. So a raw socket is another type of network socket that doesn't specify any transport protocol. It's used for directly accessing the protocol stack of a network suite, typically for testing or developing transport protocols. So, what are the role of sockets in API development? We can divide sockets into two main types based on their role in modern APIs. You have clients and servers. And for the client, a process requests or accesses information from another process or service through communication channel. And then you have the server, a process that provides a service or responds to a request from another process through a communication channel. And for the server socket is configured to remain open and passively listens for incoming traffic by binding to a socket address. It passively listens to incoming connection requests from clients and adds them to a connection queue. The server accepts the connections from the connection queue in a first in, first out manner and processes requests by creating separate process threads. And then we have our client socket. The client socket is created to get data or services from the server socket. The port and IP defined by the server socket must be known before a client socket can establish a connection with a server process. Browsers automatically identify and populate well-known ports for commonly used services. So let's talk about the network socket interface. The socket API has many different methods that can be used when communicating. The syntax may vary from language to language, but for example, we have the socket function, right? And this creates a file descriptor for the endpoint, represents the socket address family, socket type, transport protocol, etc. You have bind, which associates a buffer with the socket descriptor and gives it a unique local name. Listen, change the mode to accept new connections and associates a connection queue to keep track of pending connections. Connect, which creates an active connection when using a stream socket specifies the peer when using a datagram or raw socket. You have accept, which connects to a pending request, defining a new socket descriptor with the same set of associated properties. We'll skip over a few, and we also have close. Closes the connection and frees up resources associated with that socket descriptor. So you can look into these, maybe play around with them. Let's get into an example of a running application. So here's a screenshot of network statistics taken from a running MEVN stack application, right? So there's a few columns we want to focus on. Here's our protocols. Here's our local address, foreign address, and the state of the connection. So in the first box, each socket uses TCP, right? If you look in closely, all of these are TCP connections. So each socket creates a reliable communication channel. And then the socket address for the different services are displayed in the local address in their second column. And some of them are 0, like these, which mean that the socket is open for connections through all device network interfaces. And in our fourth box, we have the state and the status of each row. So here we can see listen, which indicates that there are server sockets passively listening for incoming connection requests. Established, which represents that the connection between, Vue.js application or the database and the Node.js server. And then time wait shows that the connection is closed from the local socket. It's waiting for the remote socket to finish sending. So in summary, we have many abstraction layers to help developers develop portable applications without worrying about all the network details, and network sockets are one of those basic abstractions, the only interface responsible for creating connections at a core level. So let's do a quiz, right? So here we need to match these answers match these statements with these answers, right? So let's start with the first one, a stream socket. So a stream socket it's a 3-tuple of information containing the IP, the port, and the transport protocol, right? And an API endpoint is specified by a combination of an API address and the port number. And a connection is established by a pair of sockets containing information about the sender and the receiver. So let's see the answer. Right? So hopefully you learned something. Leave a like and comment if you feel like I need to go into more depth or anything. Thanks for watching, and I'll see you in the next one.